In lesson 16, we're taking a look at chromosomes. Why are we looking at chromosomes? Well, really it follows on after lesson 15, where we discussed meristems. You'll remember there we talked about apical meristems, where there's active cell division that adds to the length of the stem. And we also talked about lateral meristems, like the vascular cambium and the cork cambium, that add to the girth, to the thickness of stems of woody plants. So because we're talking about meristems and active cell division, I wanted to address chromosomes, because that cell division is a type of cell division called mitosis, where one cell divides to become two cells. Now, what's critically important to happen in mitosis or mitotic cell division is for there to be an exact copying of the hereditary material, so that both of the new cells have exactly the same hereditary material as the originating cell. Now, we're going to talk about the mechanism and the process of that a few lectures down the line. But for right now, I wanted to talk about that hereditary material. And the hereditary material are the chromosomes. Chromosomes have been known for at least 150 years because when you look closely at cells, even through light microscopes at high magnification, you can see chromosomes. And early scientists were able to see chromosomes lining up in the center of the cell and separating equally before new cells were produced during mitosis. So they had a really strong clue that these chromosomes were extremely important. And later it was proven that they are the site of the hereditary material. So we're going to start out by taking a look at what makes up chromosomes. The short answer is they're made up of chromatin. And chromatin is a complex of DNA strands that are wrapped around proteins called histone proteins. So we'll take a closer look at that.